Geometry Lesson 5.2, dealing with bisectors of triangles. Once again, all this information for these different centers can be found on your note sheet in the Moodle formula area. All right, bisectors of triangles. Since a triangle has three sides, it has three perpendicular bisectors. When you construct the perpendicular bisectors, you find that they have an interesting property. All right, the perpendicular bisector of a side of a triangle does not always pass through the opposite vertex. So, when three or more lines intersect at one point, the lines are said to be concurrent. The point of concurrency is the point where they intersect. This point is called the circumcenter of a triangle. So the circumcenter of a triangle is equidistant from the vertices. So if you have the circumcenter P, that means that all those blue lines are the same. They're the same distance to all the vertices. So where the perpendicular bisectors intersect is the same distance to all the vertices. Okay? The circumcenter can be inside, outside, or on the triangle. We're really going to focus on right triangles here in a minute, but the circumcenter is the center of a circumscribed circle. The circle that contains all the vertices is circumscribed about the polygon. So the circumcenter is where the center of the circle is the same spot where the circumcenter of the triangle is. All right. DE, EG, and FG are the perpendicular bisectors. Find GC. Well, since these are the perpendicular bisectors, then they would be the same distance to all the vertices. So if BG is 13.4, GC is also 13.4. Okay. MZ is the perpendicular bisector. Whoops. Find GM if we know that MZ is the perpendicular bisector. Well, GM is right here. Well, if ZM is the perpendicular bisector, that means that GM must also be 14.5. Okay? Find GK if KZ is the perpendicular bisector. Well, if KZ is the perpendicular bisector and KH is 18.6, then GK must also be 18.6. All right? I will only ask you to find the circumcenter of a right triangle if we are doing it graphically. Okay? So the first thing you would want to do is graph the triangle. So we can see that since this is 10, this would be the perpendicular bisector of the bottom leg there. This would be the perpendicular vertex or the perpendicular bisector of that line, and they cross at 5, 3. Whenever you're finding the circumcenter of a right triangle, it is always just the midpoint of the hypotenuse, and that should be on your note sheet, I think. If not, make sure you put it on there, okay? Midpoint of the hypotenuse is the circumcenter of a right triangle, okay? So let's try that again here. 0, 0, 6, 0, 0, negative 8. So that would be 6, and that would be negative 8. So midpoint of the hypotenuse would be from here to here. So 6 plus 0 is divided by 2 is 3. Negative 8 plus 0 divided by 2 is negative 4. So 3, negative 4 would be your circumcenter. Midpoint of the hypotenuse of a right triangle for the circumcenter. Okay. In center. Triangle has 3 angles, so it has 3 angle bisectors. The angle bisectors of a triangle are also concurrent, meaning they all cross in the same spot. The point of concurrency is the in-center. All right. So the in-center means if you got P, it's the same perpendicular distance to all the sides. So PZ, PY, and PX are all the same. Remember, the distance between a point and a line is the length of the perpendicular segment from the point to the line. In-center's always inside the triangle, unlike the circumcenter. Okay, in center, inside. All right, it is the center of the triangle's inscribed circle for the in center. All right, MP and LP are angle bisectors. Find the distance from P to MN. Well, remember, the distance from P to MN is that perpendicular distance. But since these are all the angle bisectors, since QP is 5, that is also going to be 5. All right. Think big triangle on these ones. MP and LP are the angle bisectors. Find PMN up here. Well, this is 20. PL is the angle bisector, so if this is 50, this also has to be 50, so that whole triangle is 100, or that whole angle there is 100. 100 plus 20 is 120 divided by, or subtract from 180 is 60, then you got to take half of that angle up there to get 30. So 30 is the angle PMN. All right. Angle bisectors, find the distance from X to PQ. Well, once again, it's that perpendicular distance. Well, if that's 19.2 XY, then it's always 19.2 from X to any side of the perpendicular distance. Okay, because that's the in center. Once again, PQX, think big triangle. So we know that's 52. XR is the angle bisector, which means that whole angle has to be 24. 52 plus 24 is 76. Subtract that from 180, which leaves you 104 up here. And we're trying to find PQX, which is just this angle in here. So 104 divided by 2 is 52 degrees. All right, angle bisector in center. City planner wants to build a new library between a school, a post office, and a hospital. Draw a sketch to show where the library should be placed so it's the same distance from all the buildings. Well, we want a library, a school, and a post office. And we want to draw, a hospital, a school, and a post office. And we want the library to be in the middle. Well, where should we put it so it's the same distance to all the vertices? Circumcenter or in center? That would be the circumcenter. Circumcenter is the same distance to all the vertices, so you would want to place the library there. All right. And you don't really need to draw the picture. I'm just interested in knowing that it's the circumcenter.